This is the Daily Space for today, Friday, September 6th, 2019. Welcome to our new chaos. We are in the process of launching a podcast to accompany this particular show, and we're hoping that all the crazy tech that has really been breaking me these past few weeks is going to start coming together to allow us to, well, have a better experience right here on twitch.tv during the live stream, but also to allow you to download a higher quality podcast later on. So, I'm your host, Dr. Pamela Gay, and I am here to put science in your brains and not be able to see my controls on the other side of the room. This is an ongoing problem. I think I just need to get glasses, folks. I think I just need to get glasses. Today's astronomy news is filled with planet formation. In our first story, we peered deep into the Perseus molecular cloud and into a new study from the Max Planck Institute for Extraterrestrial Physics. This study explains how forming solar systems spin. There's a lot of detail in planetary formation that we just don't understand. But we can piece together the big picture by looking at star-forming systems. We clearly see stars forming in fragmenting clouds of gas and dust. As these words, they're hard, people. As these clouds collapse, they begin to spin, and it's in the heart of the spinning, collapsing cloud of gas that the material that eventually forms a protostar will collapse, turn on, and planets will begin to form. Further details are really hard to figure out, and one of the more difficult to figure out problems has been, how does the gas rotate in these clouds? Does it rotate like a solid object or like a collection of objects whose motions are determined by orbital mechanics, or is the entire thing just a turbulent mess? This new study, led by Jamie Panetta, observed 3 very young solar systems that all have edge-on disks that allow us to easily measure the rotational velocities at different distances from that forming protostar. Using the Very Large Array, they clocked speeds in these systems' cores that make the systems look like solid bodies, while in the outer regions, the motions were driven by turbulent inflow of new material. They found a single computational model that explained all 3 systems. And that model requires a magnetic field that prevents the turbulent inflowing material from falling in too fast. This limit to the inflow and new understanding of the disk motions indicates that massive disks that form massive star systems can't form fast. This work is still in its early days, but it is using observations to put solid limits on solar system formation models, limits that are observable. Here's to hoping this team finds many more edge-on systems and is granted the telescope time they need to observe them. And now I'd like to push the clock forward and look at the period of solar system formation and planetary formation that is wrought with collisions. This is a story of one result building on another. Back on August 14th, we brought you a story of how a collision between an early proto-Jupiter and a 10 Earth mass object affected how we see Jupiter today, leaving it with, and I quote, a fluffier than expected core. Yes, folks, I said fluffy. And so did the scientists doing the research. Well, the fluffy news continues with a new study coming to us out of Caltech University that predicts that giant impacts can lower the internal pressure of planets, essentially turning them from dense spherical bricks into light and airy worlds. Just like whipping your cake batter and mixing your eggs can introduce air into your favorite foods, collisions can vaporize material, mixing gas into your favorite planets. They also found rapid rotation created by these collisions can also expand out the planets. This research helps us understand our own planet, which experienced a massive moon forming collision billions of years ago and has continued to be bombarded by rocks, large and small, all the way up until today. Early on, when things were a bit less solid, each impact changed the chemistry of the Earth's outer mantle ever so slightly as metals from impactors interacted with the materials in the Earth. Our planet's internal pressure should have affected those reactions in very specific ways that should be observable today. When we look at the chemical composition of the mantle, however, we see things that indicate that our planet's internal temperatures were much lower than had been previously expected. With these new models, we can now match what we observe here on Earth and say, yes, if you want a light and fluffy planet, throw a lot of impactors at it while it's still forming. And that means our light and fluffy planet had a lot of impactors thrown at it while it was still forming. All right, so that's enough with the cooking analogies. Clearly, I am hungry, and I didn't switch slides. I thought I switched slides. I didn't. Here's the picture of how you get a light and fluffy planet. It's not pretty, people. It is not pretty. Going on to our next story for today. It was only in 1995 that we found the first regular planet orbiting an alien star. And in these past 24 years, we have gone from a handful of worlds that we knew about to thousands of confirmed planets orbiting every possible kind of star. Many of us hope that some of these worlds support some kind of life, although I, for one, hope that life stays far, far away. But if that life is out there, the question becomes, how do we detect it? Our best hope may come from looking at distant atmospheres in search of the specific signature of life that might appear in an atmosphere. From pollution from cars to oxygen from plants, life changes our world's atmosphere in all sorts of potentially detectable ways. Now, for the first time, scientists have determined what our own Earth would look like if observed by distant aliens. For more than a decade, Canada's SciSat has circled Earth looking at how sunlight passes through our atmosphere, getting scattered and absorbed by particles of gas. Designed to study our world's ozone layer, the data can be repurposed to determine life's fingerprint on our atmosphere. Just like human fingerprints on objects, life's fingerprints on the atmosphere could be hard to see like a fingerprint on wood or easy to see like a fingerprint on clean glass. According to study researcher Nicholas Cowan, who worked with student Evelyn McDonald, the JWST, if launched, may be able to detect a biosignature like Earth's, a biosignature of methane and ozone, if it peers at a distant planet long enough. Now, this would be tricky work, requiring repeated observations of a transiting planet, perhaps across years, as we wait for the world to orbit back in front of its star over and over again. But if you're going to confirm life in our universe, a slow coming to terms with its definitive reality may be the best way for Earth society to get used to that particular idea. Okay, that's it for today's news. That went really quickly. So, yeah, that's it. I will now take your questions and ask you to please at CosmoQuestX as you type them into the chat. That will really help me find them. Let me remind you that the Daily Space is a production of the Planetary Science Institute, and it's hosted by myself and Annie Wilson. Yesterday, we launched a new podcast edition of this show. If you want a roughly 10-minute chaos-free listen, click over to dailyspace.org and check it out. We're still working to get this podcast listed on all your favorite podcast directories, but it's coming. Just be patient. Each live episode of The Daily Space is archived over on YouTube. If you miss an episode here on twitch.tv, check it out later on youtube.com/c/CosmoQuestX. No X, just CosmoQuest. Today is filled with all of the mental typos. These episodes are edited and produced for you by Susie Murph, whose birthday it is and whose anniversary it is. 22 years of marriage, and she has a senior in high school and a college kid to show for it. And wow, that's a lot. This means she's paying tuition, and those bits that you give this show, they help her pay her daughter's tuition. So if you want to give her a really happy birthday, you know what to do. Okay, so we are here thanks to the generous contributions of people like you who allow us to pay our staff. That's Susie and Annie a living wage. Every bit, every sub, every patron over on patreon.com/CosmoQuestX, all of that goes into making this show possible. If you can't give financially, we really do understand. I'm going to stop looking at my teleprompter. We really do understand. There are lots of other ways that you can support the show. One of the best things you can do right now is just get the word out. Tell a friend, tell a family member, tell an enemy. Tell them all to get online and watch, or give us a download and listen. You never know what doors you're going to open by spreading the good word of science. Okay, so thank you for the bits. I hear it. Keeper of Maps, thank you so much. Eddie is dead asleep on the other side of the room. That ends this part of the episode, and I am now going to scroll back through chat and answer your questions. Oh, and while I do that, I'm also going to remind you that we're in the process of coming out of hiatus for all our shows. Later today, we're going live with our first episode of the season of Astronomy Cast over on youtube.com. And our episode is going to be the reusable rocket revolution. And we're going to take a look at how SpaceX's extraordinary idea that you can catch the bits as they fall out of the sky has led to lots of other companies changing how they do rocketry. I subbed for 20 months in a row, or 20 months, currently at a 16-month streak. Woot to me, I guess. Bad Panda is saying, 3 hours ago, I was really confused about why there was no daily space. Then I realized my iPad was still on Eastern time. Bad Panda Bear, you must get up really early in the morning if you'd been awake long enough for that to be confusing. I am so sorry. I am so sorry. Thank you for the bits that are at the bottom of the screen scrolling. Thank you, Kevlar 1066. Raj Luthra points out ISRO will be landing its Vikram lander today in about 2 hours. Thank you, JB McCool. We are actually having this really weird collision of everything happening at once. Annie, my co-host here on this channel, has a meeting she has to go to during the Indian landing, and we're going to be recording Astronomy Cast live during the Indian landing. So I can't tell you where to look and what to do. Thank you, Baryonic Man, for the bits. Thank you so much. So today is a day of all the science. All of it is occurring live streamed to you on all the different platforms. Pick one, go back, watch the others on video on demand, and watch them all, just not simultaneously. That might be hard. Okay, scrolling and looking back up for questions. You guys are all so awesome today. And I have coffee, which is important because I also have Concred. Yes, Paranor, you do need a podcast command. I meant to message that to you earlier today, and I totally forgot. Um, Larry, we're totally working on the intro. I haven't got the new intro that we're developing kicked on over to this software yet. But if you listen to our podcast, you'll notice that my audio is screwed up because I recorded at the wrong bit rate. So it sounds a little bit weird. But the music in the background is perfect-ish, perfect enough. Um, Hey, Raj Luthra, now I'm seeing your question. I have a bad head cold, so if I sound a bit nasal, it's because I am. Sorry. Um, Coffee is amazing, Paranor. Coffee is always amazing. Um, okay, scrolling and looking for questions. Larry's asking, only inside of air. It probably is liquid metallic hydrogen, right? Um, I need more context to that question. Larry, can you ask that question with more words? I'm sorry. I just don't understand. And I'd like to give a shout out to the best mods ever. You guys make it so that I never see any of the bad stuff that goes on in chat. I kind of adore that in all of you. Looking. Oh, I hate having a head cold. Hate, hate, hate. But I love you, Ton Van Scooter, for subscribing as a tier 1 for 16 months. Thank you so much. So Fenmil asks, on the new gravity anomaly in the south pole of the moon, any chance it might be a leftover from the Earth Thea that formed the moon? Yes, that's actually one of the ideas that they have is that not so much the Earth Thea, but it's a leftover of the impactor that hit the moon and formed the South Polar Basin. So the impactor that hit Earth forming the moon, everything was just destroyed, melted, splashed. Nothing really left over. Everything was mixed together and redistributed. But whatever formed the South Aitken Basin, bits of that could be left behind. So that's one of the theories there. Larry, I'm with you. I type perfectly in my mind and not so much in reality. My favorite pastime in typos is to write a word that is similar to the word that I was thinking and absolutely not the word that I was thinking. Um, yeah, lots of word substitutions. My brain is weird. And once again, thank you, Keeper of Maps, for the bits. I see all the birthday congratulations to Susie. Yes, happy birthday, Susie. Eddie is dead asleep on the other side of the room. He's terribly adorable, but dead asleep. He's quite alive, I'm going to point out. It's just the sleepy part. Thank you, Kevlar, again. And thank you, JB McCool, again. And thank you, Baryonic Man. I'm going to need to sub Paranor just to get his, icon. Okay, so that seems to be all the questions we've got for today. So I'm going to round us out 5 minutes early, go record this and turn it into a podcast, and prep for Astronomy Cast. So hopefully I will be seeing many of you over on YouTube in 1.5 hours as we bring you the first episode of season, and we're going to change with it. Always, all of you are here. And just to say it again, this is a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to, exploring our solar system and beyond. Annie, I totally forgot to open the thing that I have to click to start the credits. If you can start the credits, you would be even more of my favorite human than normal. You will always be my favorite human, but even more than normal. This is a production of the Planetary Science Institute. We are made possible by the generous donations of you. Your bits, your subs, your patronage over on patreon.com/CosmoQuest is what allows us to pay our bills and really to pay our people. And that's the most important thing to me. Thank you so much for all you do. And if you can't give financially, we totally get it. The best way you can help us is to just spread the word, to let everyone else know that we're here and they are welcome. You never know what doors you're going to open by introducing someone to science. So that's it. Wherever you are in the world, have a fabulous morning, evening, or afternoon. Remember, we now have a podcast at dailyspace.org. And go outside, look up, and then get inside and learn science. Bye-bye.